Here at Milestone, we're working on a revolution, and this revolution is called Neural AI. It's the first time that it's been implemented in a racing video game, and it will change the player's perception. First, we will apply this to the artificial intelligence of the player's opponents. It's a tool that has infinite possibilities. To work on this, we searched for collaborators who are experts in this sector. We found them surprisingly close to home, here in Italy, a company called Aerobics. AI is the part of a game that determines the behavior of characters, or vehicles in this case, that are not controlled by a human. They have to react to situations occurring in an environment, and in traditional AI, they do that based on instructions written by a programmer who comes up with the rules describing how the agent must react to that environment. Neural AI, on the other hand, is the bottom-up counterpart, where agents learn autonomously which controls they need to operate in order to achieve an effect of realism or performance. For training neural networks through reinforcement learning, we use tools that have become the state of the art. We use PyTorch, an open-source framework that we know well and that allows us to do a lot, because it doesn't impose a lot of burden on those who use it. With it, we can do our job in the simplest way possible and focus on the hard problems, which are a whole other world of issues associated with training in-game.
The designers need to be teachers, and this is very different to their previous role. In the past, we just had to balance out variables. Now we have to learn how to teach, and this has completely changed our perspective on artificial intelligence. We had to begin structuring a whole new area of work.
We tell the neural AI which objectives it needs to complete. We tell it which actions will give it a negative result and which actions a positive result. And then it's up to the AI to learn which way is best to obtain the objective.
The result is a very realistic experience, similar to a human player. But this is an emerging result, as opposed to a top-down prescription. A neural network can recall the neuron as a conceptual analogous. Mathematically, they're quite close. Biologically, they're not. A neural network model takes an input, it multiplies it by numbers, and those numbers are the results of training. They are estimated automatically. How do we determine those numbers? We provide an objective, and we try to determine the values so that the objective is achieved. It's the objective that we prescribe in the case of the game, and the objective is to go as fast as possible.
We started out by studying literature, basically checking what is available and what the state of the art in this field of reinforcement learning is. The most popular model is actor-critic, aptly named because one of its components, defined as the actor, is the part of the model that makes decisions. In the case of autonomous driving, it's all about accelerating, braking, turning left or right, etc. Once the action has been triggered, another component is responsible for evaluating that decision.
When the neural AI is at the beginning of its learning process, in its infancy, it starts to explore. In scientific literature, this is called the trade-off between exploration and exploitation. But when it comes to exploration, I'll trigger certain actions to see how it reacts and what the consequences are. For exploitation, I'll use my knowledge and experience to obtain a reward.
Neural AI doesn't start with commands, but rewards where it will receive or lose points. Basically, it's told what is good and what is bad, how to gain points and how to lose them. After this, it's given control of a motorbike and free to move around.
We give it a series of episodes throughout its learning process, and for each episode, we observe how the race concluded. We analyze its performance and assign points.
We can go back through the history of the model and verify which inputs contributed the most to a certain output. We had to design eyes for the neural AI. We had to give it sensations. However, what makes the biggest difference is that the neural AI remembers what has happened. This is an enormous advantage because it learns from its mistakes.
We chose neural AI because it has the potential of adaptability and complexity that is superior to the traditional model. It can internalize the driving systems, the maneuvers and techniques, which allows it to perform more naturally and imitate human behavior. This is what makes the difference.
Neural AI has the great advantage of circulating the track hundreds of thousands of times in a few seconds, effectively receiving the same experience as a professional racer. This allows us to gain performance over time in a few days. We gave the AI the ability to understand grip, exactly how a gamer feels the controller vibration when the motorbike is about to slide. This allows the AI to refine its behavior.
Getting the neural AI to race in a group is definitely a difficult task because we have to try to be fast without overdoing it. We have to try to push to overtake those in front, but most importantly, we have to try and keep an eye over the whole situation to avoid having accidents, touching other opponents, or the players whose movements will be more unpredictable and varied, compared to the AI, who performs like a professional racer.
We can give priorities to the neural AI. Through the scoring system, the priority is not to hit the player or the opponents. A secondary priority could be not to get out of sight, but this would mean, in order to avoid the player, it can go slightly off track. This is exactly what happens in real life to avoid accidents. The neural AI went through a lot of intensive training under different circumstances. We created various starting grids and race starts all over the track. Not just the classic start, but procedurally generated situations. This allows for different group situations, even non-realistic, where they might start halfway through a curve. But this helps to refine their senses and ability to avoid obstacles in unpredictable situations.
As it's a computer simulation as opposed to a real person or real life, it can accumulate 100 or 200,000 experiences in a day's work. I don't believe anyone has raced 200,000 times on a single track. So this allows it to accumulate an experience second to none.
We're able to create special sessions that even professional racers don't have in such a structural way because we need to develop a family of racers. We started 2 years ago, and in the beginning it was a research project. We weren't sure how or when we could implement it. We had to really integrate ourselves with Milestone. We had to develop a software in order to allow the training process to run as fast as possible, to have as many attempts as possible to achieve the best possible result. Neural AI allows us to obtain track times that are 3 or 4 seconds faster. This gives us a neural AI that can compete at the level of the most professional MotoGP gamers. Group performance can only be judged using a game controller and competing with them to see how they respond.
Neural AI has the ability to do things that we didn't think were normal. Every once in a while, we saw the bike drifting off the curve, so its behavior was sometimes almost too human, because it decided itself to generate a certain racing style.
Just like in real MotoGP or in any other class, losing 0.3 of a second means placing yourself below 2 or 3 racers. The results are always improving because we still want to perfect some behavioral characteristics. We would like to reproduce some real-life situations, but it's all about refining. The majority of the behavior is finished, and it's very precise, aggressive, and very human. The key for an artificial intelligence application is trying to find an area of work where a solution that is predefined or static doesn't work. You need to try to make use of it in an area where it's necessary to be very flexible and very adaptive, where the solution isn't obvious. There are many possible applications, and we're investigating them. We're thinking about it. We still haven't started working on a series of possibilities, but they're there. It's the future, and they're definitely something that could change the way of thinking about creating and taking advantage of in-video games.